Hello everyone, you've got to take a seat. Our next speaker is Fernando Diaz. Fernando is from VirusTotal, who we were here last year as well, and they're a client sponsor of AusCERT. And today he's talking about his investigation into some of the hunting he's done in BT, I guess, about the infamous Android banking trojan Copa. Please welcome Fernando.
Can you hear me? Okay. Hello everyone. Thank you for being here today. Also, before starting the actual talk, I want to thank the staff for organizing this conference. I've just gone around, it's awesome. And also I want to thank them for the invite, because thanks to them I'm able to be here. And well, I hope that you enjoy the talk. And before actually getting into the content of the talk, I'm going to introduce myself a little bit. So I'm Fernando. I'm a software engineer at VirusTotal, and my main focus of work is the development of dynamic analysis solutions, what you know more commonly as sandboxes. And before that, I've been working with instrumenting banking trojans to extract configurations from them. And instrumentation has really stuck with me, so I developed a free resource to learn to use the free toolkit and learn to instrument binaries in various platforms. You can contact me in my work email, or you can contact me through Twitter, and I'll get you an answer as soon as possible. Okay, so let's get to the actual contents of the talk. So what's Copper? Copper is an Android banking trojan that's targeting both crypto exchange users and bank institution users. Traditionally, banking trojans were only focused on banking applications, but since crypto has become popular, they are also shifting their attention to these exchanges. What's interesting about this banking trojan is that they are mixing up different regions when they are targeting in some of their campaigns. So usually you will see that in a banking trojan, they are targeting a very specific region of countries because they have more control of what's happening in the infection stages, or they will just have a very wide list of injections ready to attack lots of countries. In this case, they are mixing up different regions. So you will see, for example, they are targeting Japan, they are targeting New Zealand, and then they are targeting South America. Or maybe they are targeting the US and then Poland, so completely different regions. So this will get the attention of more people, and I thought that it is done to distract, but I don't really think that's working out for them. To this day, this family is still active, and their origins go back from Exobot, one of the variations called Exobot Combat. Another thing is that the functionality is rather small. They don't have lots of features, but the features that they have are enough for harvesting all the important information. Here is an example of one of the campaigns. You will see that there's banks from New Zealand, there's banks from Japan, then there's banks from Spain and from Portugal. But when you reverse engineer the sample, you will see that there's no strings for Japanese. So this campaign, even though it is targeting Japanese users too, they have injects ready, there's no language strings for Japanese. So are they really targeting these regions? What is the purpose of this? This is something that really caught my attention. Okay, so now we have the introduction. We are going to have now a brief overview of the capabilities. And as I said, the capabilities are rather small compared to other malware families. And also in this scheme, I have omitted all the common features that really are interesting to overview. So one of the main features that they focus on is the VNC feature. They try to abuse the gesture dispatcher API to actually make gestures on the devices, and also to grab information from the clipboard and from some events. And then they also abuse the accessibility API to act as some sort of keylogger. It's not a very detailed keylogger, as you will see, for example, in Windows malware, because they are limited in a great extent by what the accessibility API grants to them, but it is enough for them to actually get interesting information. And then they also try to take advantage of this feature to grab any PIN or password codes that they can extract via accessibility. So, well, as I said, VNC is used to observe victims' screen. The command and control can turn this feature on, and they leverage the media projection API to send screenshots every second and more or less act as a VNC. What's interesting is that to avoid conflict with other VNC software or other remote administration software, they have a feature to actually uninstall applications, and usually they include TeamViewer applications or AnyDesk applications to ensure that they are the only ones having VNC access to the device. So they try to activate this feature at the same time with the keylogger feature, and they more or less get the story of what's happening in this device. The next thing is blocking push notifications. This is seen also is commonly seen in banking malware, and every push notification that you receive is logged by the malware. They have a very detailed overview of what's happening when you receive a push notification, and every action is sent back to the command and control. So it has two main purposes: minimizing antivirus software, which we will see later, and also to hide bank and SMS notifications. So the idea is that if your bank application sends you back a two-factor authentication code or a notification that you have sent money to somebody, you won't see it on your side. They will receive the actual notification, but the user won't notice that something's off. So here's an example of what they do. They check the uptime of the sample just to be sure that they are not intercepting notifications way ahead of time. And they configure how much time they have to wait to actually block these notifications. And then if it's one of their monitored packages, so if it is the target bank account, then they will cancel the notification. The user won't see it. But as you can see here, they're actually using the string builder to build a string with all the information, what package it was, the contents of the notification, and then whether they have successfully blocked it or not. So they get a really good overview of what you have received, and then they hide it from your site, and then the user probably won't notice what's happening. The other one is minimizing antivirus software. And when I say antivirus software, I don't really mean antivirus itself, but rather security products. What they try to do is that to avoid being intercepted by an antivirus product, they prevent the user from accessing it. So they are very limited on what they can do. So what they do, of course, is they block any notifications you might receive from your vendor, but they also block the access to the application. So when you access it, it goes again to the home screen. So if you access your antivirus product and instead of seeing the warning, you will go back to the home screen, and the user won't notice what's happening in there. The next thing is managing SMS when the device is infected, which we will see the operation sites later. They are able to control what's happening with the SMS permissions. And well, this is commonly seen in Android malware, in mobile malware. But what's interesting to mention is that they have, through SMS, an auto-testing feature. And this feature actually is used to test out that all the components and the configuration files are working as intended. So whether the configuration has been altered or if there's been an error when storing the configuration files, etc. The next one I want to mention is smart injects. So what they do is that they not only they block the notifications, but they also need to get the credentials from the users. So they have a list of applications they want to target, and then they use this feature that what it actually does is to store to show using a web view, a browser view, which is transparent for the user, with the contents of a phishing page. So the phishing page, I mean, for a tech-savvy user, they won't notice that something's off because, well, they will notice that something's off because the phishing page and the actual login page might be quite different. But for an average user, they might just think that, well, the login page has changed, and then they log in as usual. Each web view has some settings that are received from the command and control, but the most important one is the data. So they use either an embedded HTML from the command and control or a remote URL. They have a brand icon stored in base64, and they might have, if the HTML itself is not self-contained, a different HTML for actually showing up when the credentials have been captured. So making these phishing pages for each bank is it actually takes a lot of time. So there's a market for these injects. You can buy injects for some banks, and they are quite credible for what they pay for. And well, this complete list of applications that are targeted are downloaded during the registration stage, which we will see later. The two remaining features, I'm just going to mention them because we have seen uninstalling applications is what they use to remove any competing software or to remove any unwanted application on the device. And then they also have USSD, they can send USSD commands when they have control of the device. So now we have a good overview of the core features of this family. And the next thing I'm going to mention before getting into the operational side of things is distribution. So how do the culprit actors actually manage to get these samples into the victim's devices? Usually, attackers in mobile malware, they have a very limited set of options, and they need either a dropper, so they need to sneak an application into different application stores and manage to survive there before they are detected and deleted. But since they will get automatically deleted or reported easily, it's not really a very good way to actually infect as many users as possible. So what they do is that they use advertisements. What they do is that they try to host advertisements in shady websites. So for example, when you're trying to download or watch a movie online, and of course it's not a paid service, it's an illegal one, then you will see these kind of advertisements that are quite aggressive. So they are aggressive in the sense that it's very hard to actually close them, or you directly get redirected to the final page or the final payload. Here is an example. You will see that there's two different languages, and the reason is that when I was making the slides, the final payload died, so I just used a different one. And you see that the user receives a warning message where through the user agent, they get the mobile version, etc. They tell you that your device is infected, and then they try to get you to download an antivirus or anti-theft solution, which you see on the right side. So there it says that you're going to download a anti-online theft application, but actually what it does is right the contrary. Right, so there's this option, and the alternative is that they directly point you to the download itself. But this is harder for them because they need to convince the user that they need to install the application. So where do they host these payloads? Well, one of the common patterns that they use are GitHub accounts. Why are they using GitHub accounts? Well, they have various reasons. The first one is that they can create accounts for free. It's not very hard for them to create accounts there. They can have several repositories, and by pushing different applications, they get several direct download links. And we have noticed that there's accounts with almost 1 year of samples being pushed to GitHub without being noticed. So for example, this Uliak Nasiba 888 GitHub account, they started pushing samples in September. Then they had some gaps pushing. Then they started again with some waves, switched accounts, and the pattern repeats over and over until the account was actually reported. So you see, it's been 8 months. It went unnoticed. The samples were there. You could download them. And for them, it was very, very easy. If you take the account down, they make another one. And that's the way they get to host samples. The other way is Discord. So with Discord, they are able to actually upload samples there. The samples size is very small, so they fit within Discord's free account size limit. They can create Discord accounts very easily too. And the thing with Discord is that it's even easier than GitHub, because you can just upload a file there, and if it doesn't get automatically removed, you get a direct download URL. You don't need to be authenticated, so they can just upload samples there, get download URLs, and keep doing it all the time. If their account gets removed or their file gets removed, they just upload a new one or they make a new account. And as of recently, this limit, I think it has increased. I believe it's 25 for free accounts, 25 megabytes. So it's even easier for them to actually host these payloads. And the other one is compromised websites. This is a more common pattern. They try to use websites that have poor security, or because they are outdated, they don't take, they are an easier target. And what's interesting to mention is that not only they focus on poorly secured websites like WordPress or content management systems, but they actually try to host payloads in government domain applications. So the nature of these sites kind of provides them a somewhat safe environment for hosting their payloads. Now we have more or less an overview of how they actually get the samples into the victim's device. As I said, if they are not using a dropper, they need a very convincing message, and that's why they try to get the user scared to actually install the target application. So they need some sort of social engineering before actually getting an operational sample in the victim's device. So now we're going to check over the operations side of things. So let's say they have managed to get the APK file installed in the victim's device, but that's actually not enough. They have some setup before actually getting an operational malware in the device. So we are going to go step by step to see what they actually do on each step. The first step is actually unpacking the sample. When you try to reverse engineer the sample, you will see that there's actually little to no code that points to be malicious. It just looks an APK file with very little code. But you'll notice that there are some dynamic, there's some libraries stored in the resources section, and that on application startup, one of these obfuscated name libraries is actually being loaded. So what they do is that when you open the application, the first step, they load this library, and then we have the first step on the unpacking stage. This library, what it actually does is to decrypt the payload using RC4, and you see here an interesting pattern on their side. is that the key is usually shared among samples from the same campaign, and sometimes they don't even care to change the default builder key. So if you have one of the keys, you can extract lots of payloads from various samples without actually reverse engineering any of them or getting the actual key. You see here in the resources section, one of the folders in the raw folder, this family usually stores here a file with no file extension, and when you try to check it out, you see that there's a blob of data with nothing that we can make sense of. The reason, of course, is that this is encrypted, and what's present in there is an actual DEX file. This DEX file is loaded then in memory and then contains the real code. Why is it suspicious that there's a payload? Well, as I mentioned, there's very little code in the initial application, and also when you check the Android manifest for the application, they are making references to classes that are not present in the code. So when you see this pattern, it's either they have a dropper, a second stage dropper somewhere, or they have some payload hidden within the application package. So we get the first stage, they do the unpacking. They get the runtime library, and then they load the real DEX file. This DEX file also has obfuscated strings, but luckily for us, we can just instrument or just copy the code for decryption they have, and then we can run the decryption code over and over all the strings. The next thing is actually getting permissions. So you see, without permissions, they can't really do anything. They are very limited by the operative systems, and every version of Android limits them even more. So they need to get as many permissions as possible, and they need to make it somewhat credible to the end user. So you see in the previous slides, you have downloaded some kind of anti-theft protection software, but now when you install it, you see that it has become Chrome. So it's not really Chrome, of course. It's an application icon that mimics the real Google Chrome. So they will try to get permissions for SMS to control telephony so that they can control calls and also to control SMS. They try to get device administration permissions because this way they can project, so this way they can have the VNC feature working. They can show overlays, so they can show the phishing pages when you're accessing your bank applications. And then they can also perform hand gestures on the device and control the clipboard, etc. And of course, they try to disable Play Protect. So if they try either using gestures, so when you end up in this screen, they use a gesture to disable the service. But in case that it doesn't work, it will repeatedly show the user the same screen until they manage to actually get the user to disable the service. The reason is that while they have this service enabled, they will most likely get deleted at some point, and they don't want to continue doing anything else if this service is working. So this is one of the requirements to actually go forward. We have the first two stages. We get the unpacking stage, and we'll get the permission stage. And the next thing is understanding how they communicate with the command and control. All the communications are done via HTTPS, and they use a rotating list of command and controls. With rotating list, this is something common also in Windows banking malware. What they do is that when you are infected, you have a default list of domains, and if one of these domains fail, they go to the next one in round robin until one of these works. Unless all the domains are taken down, the sample will eventually become operative. So what they do is that each message that they send to the command and control is usually a JSON file, a JSON post request. They first run ACE ECV over the text to encrypt, and then they run over this encrypted text over base64, and before sending it to the command and control, they gzip compress it, and then use level 9 compression to send it to the command and control. The same thing happens back from the server. The server sends the data, so you have to gzip decompress the data, you have to decode the base64, and then you need to decrypt the payload or the text using ACECB. Only then you will get what they are actually speaking to one another. To actually get this key or the algorithm they are using, you can instrument the constructor for secret key spec, and that will give you in the constructor the key that they are using and also the algorithm. So if something changes and you're instrumenting this API, you will get the actual key information, important information to get the communications decrypted. So now we have the first 3 stages. We know that they need to unpack themselves. They might or might not actually delete the unpacked dex file, depending on the version, depending on whether they have configured it. They get the permissions, so they can do all they want with SMS, with projecting VNC, and with overlays. And the next thing is, well, communicating with the command and control using this pattern. So what do they send to the command and control? First, you see, I mean, this is not compressed or anything. This is not changed. It really is something like this, where you see here XC. XC stands for request type. So they have several request types that are sent to the command and control. And VR is what they understand as register. So when they send a request with these parameters to the command and control, it's saying, hey, I'm a victim, I'm in this device, please register me and give me all the data that I need to go on. So in this request, they send key information, important information from the device. So they send email information, they send the list of installed applications, the country, the system version, the system language. They need the system language to change the setup stages, and also the uptime and the keylogger status. There's more settings there's more information that they send. For example, they send all the logs from the initial stage to up to this point. And the reason they do this and send all this information is because the command and control needs to verify that this is a worthy target to them, because they don't want to infect sandboxes, or they don't want to, if it is a known pattern, for example, same email, same list of installed applications, then they will reject the victim. So now we have that every communication first tries to send a registration request, and then if the sample, if the malware is approved by the command and control, then they will receive the actual configuration. So in this configuration, they have the list of alternative domains. So not only they have the command and controls from the first stage, the hard-coded ones, but they also receive some extra domains from the command and control in case something goes wrong with the first 3, 4, 5 domains that they have in the original code. They send which antivirus software to minimize and what banks to target. So they receive the list dynamically, and they can change this anytime. And then they also get more information, such as, do you need to turn up VNC? Do you need to turn up the keylogger, etc. One of the things that they also usually change is the tick rate, which is they have a sync timer, and depending on the sample, it varies wildly. For example, yesterday I was checking one, and it had a 500 seconds timer, but sometimes they just have 1 minute between requests. So they try to not, I mean, they depending on the country or on the device, they just, well, how they have set it up, they have different timers for synchronizing data. So up to this point, we have understood how to distribute the samples. Now we know the functionalities and, well, the features that they have. And then we also know the operational side of things. We know that once they have installed an application, they have to follow up all these steps. So when I was analyzing this, I noticed that by taking a look at the notifications, at the network communications, it's possible to actually simulating that you are infected without actually running the sample on a sandbox and without actually, doing any analysis of the sample. The only thing you will need is you need to have extracted previously a list of applications, or a list of keys. And if you have a list of keys, then you can rotate this list of keys until you get the one that the command and control understands. So I'm going to showcase this emulator. Let me see. So I'm trying to get a big screen here. Can everyone see it? Okay. So, yeah, I can, right? So I recorded it, I think, yesterday night, so it's very, very recent. What I'm doing here in the video is that I'm just, okay. So I'm just getting one sample that has been uploaded very recently. In this case, it was uploaded yesterday. And then they grab one of the communicating domains and run it over the emulator. So when the emulator does is it registers ourselves in the command and control, and we get the list of the alternative command and controls from the registering stage. Then what we do is that we store the information that we have received. And we get the whole complete configuration that is sent by the command and control. This way, we don't need to do anything else from the SOC point of view. We now have the initial domains that are used in the communication in the first stages, and then we also get the extra domains used to communicate with in case the first ones go down. Then you see, well, the settings of the other features that I have mentioned in the previous slides. So you see they have the minimizing delay, the uninstall applications delay. They have the last setting, the net delay, is the synchronizing delay. And, well, with this, we have all the information we need to actually take down the whole campaign. Here is the end of the presentation. I hope you have enjoyed it. This emulator, you can send it to, you can just send me an email from your work email, and I'll just send the emulator back to you if you want. And the reason is the code is not on GitHub, it's obvious. If I publish it, then the threat actors will know how they are being fooled, and it will make our lives harder. So you can contact me again through this email or just Twitter. And, well, if you have any questions, let me know. Thank you.
Yeah, thanks, Fernando. We've got a little gift for you.
Okay, thank you.
You're going back all the way to Japan, is that right?
Yes.
Yeah, well, I hope you can fit it in your bag. Or
yeah, I'll try. I'll
trade it. Maybe someone would like to do a deal for some extra VT API access, who knows? Yeah, there was one question I had, I guess, and I guess was, have you seen any apps on the actual Google Play Store that have been infected with COPA?
I've seen some applications in the Play Store and in other market applications, but they get deleted very easily. That's why they try to get the Play Services service, they try to get it disabled, because if it is running, they will get detected easily. And if someone reports them, it's actually very short time between actually the report and the takedown. So.
Yeah, it'd actually be good if you probably met. There's a lot of people from Australian banks here, like our last speaker, who probably would love to talk to you about how it's affecting them, some of these banking trojans. So yeah, so please thank Fernando again. And